Okay, we're going to be talking about the geoforensic evaluation of permeable paving. And again, I apologize for the technical problem. We'll try to fix it on the next time. Permeable pavers are used in residential and commercial projects, and they kind of work like a detention pond, essentially, uh, underneath the paving. So today we have a lot of engineers that have registered. Last time I checked, there was like 220 people RSVP'd. Again, sorry for the technical problems that we have. My contact information, of course, is my email is de@geotecheng.com. Phone number is 713-699-4000. Okay. This presentation is going to be on the YouTube channel. So you go to our Geotech Engineering and Testing YouTube channel and you can see the presentation. If you have any questions, do it in chat and or Q&A, and hopefully I can answer it. Again, we're just getting used to using Teams. We used to use Zoom. We had a lot of problems with it, and we're trying to learn Teams now. Geotech has been around for about 39 years. We do geotechnical, environmental materials, and geoforensics with a lot of construction defect cases. We have about 60 engineers, geologists, technicians, and we work all over Texas, Louisiana, New Mexico, Oklahoma, and Arizona. And we have our own rigs, so we get out there and get the job done quickly. This project is about permeable pavers, and we're going to be talking about different types of permeable pavers. We're talking about infiltration tests, how much base permeability they have for these pavers, for natural soils, for pavers or pavements and natural soils. And also we run it on a concrete as well. So we got zero permeability for that. And we have a bunch of field infiltration tests that we did. We'll look at some of the certain types of permeable paving. Rain Creek, really a good one. And then we did some borings and soil testing on these things. We did laboratory testing, and we ran engineering analysis. And then we talk about the results and conclusions and maintenance of the permeable paving and pavers. So with that, let's see, any questions here? I still don't see any questions. So in here, so I don't know if this thing works or not, but anyway, hopefully y'all can hear me. Permeable paving. Basically, the definition of the permeable paving is a proven is reducing stormwater runoff while supporting pedestrian and vehicle type loading, and many of the laboratory and in situ tests, and indicate that they have a lot of cost saving benefits in terms of storage. FHA has got a good program on that, so you can look at the FHA manual on permeable pavers. Typical use of the pavers, I mean, you see them all over the place. If you go to City of Sugar Land, you can see this thing out there. They have pavers out there. Some of them are permeable, some of them are not permeable. And the City of Sugar Land, you see them all over the Woodlands area. So they got them all over the place. They use them for parking. This Harris County flood control. You go out there and they have this parking over there that they got pavers there, permeable. Again, there's parking lots, more parking lots. That's a typical kind of a sidewalk deal. Again, some of these are permeable, some of them are not. Sidewalks, driveways, more driveways. That's permeable paving here. Really a good system out there. We're going to test this thing here. Permeable paving. It's made out of aggregates and concrete. Very, very water flows right through it. Permeable pavers. The typical design on these things is, you can see over here the paver itself. You got an open graded bedding course underneath it. Below that, you got an open graded base reservoir. Sub base underneath of that is open graded. That means open graded means that the aggregates over there, they just kind of, they have voids in them. They don't have a nice gradation on them. And then of course you got the basically, if you need a drain in here, underneath that you got the geotextile fabric. Most of them, they do have that, and compacted subgrade. And you know, these subgrades should be stabilized if you got heavy traffic. If you're doing a driveway uh, or a little parking lot, you may not stabilize it, but we recommend stabilization. Here's another drawing from Keystone that shows the paver. They've got the layer of aggregate in here, bedding course. You know, basically about 2 inches, number 8, and below that they come in with uh 4-inch minimum thick of you know, number 57 stone. Below that they come in with of course, here's the geotextile here. Here's another set of aggregates, and then you got the drain pipe. So it's kind of involved. And here is the subgrade, got to be compacted. Um, Permeable pavements. Permeable pavements basically is this is what we call compacted drainecrete, and then you got underneath that you got the, you know, 1.5 inch rock. Below that, of course, you got geotextile, and you got compacted subgrade. That's for a driveway, which is fine. You can do that for a driveway, 4-inch and 4-inch. That's pretty good. Lasts for a long time. Standard pavements, you got 4 inches of the compacted rainquake. Below that, you got the compacted rock, about 8 inches. Below that, you got the geotextile fabric. Below that, you got, of course, the compacted subgrade. Here, it'd be really nice to stabilize, you know, this. If it's in clay, lime stabilize it. If it's sandy soil, you do lime fly ash, like 8 inches before you put this in for pavements. And definitely for heavy pavements, you got 6 and 8 geotextile fabric. Again, we recommend lime stabilization in clay, 8 inches, or lime fly ash in sandy soils. Make it last a lot longer. Construction wise, you know, you got to go out there and do the proof roll, that subgrade. Get a loaded dump truck, about 25 to 50 tons. You run on it. Make sure you don't have rust. It's not acceptable. It's not acceptable. This is not acceptable. You got to compact that soil if it's clay with a sheep's foot. And if it's sandy, of course, you compact it with a steel drum roller. Make sure it's nice and compacted, 95% standard Proctor density. That's the compacted soil with a sheep's foot. You run the density test with a nuclear gauge. Make sure this thing is passes the density. Again, if you got heavy loads on it, like a roadway or something, I would recommend, you know, stabilization, chemical stabilization, lime or lime fly ash, depending on the soil. If your soil is clay, use lime. If it's sandy, use lime fly ash. And then you put your aggregate on, and compacted aggregate. Here's a steel drum roller going out there and compacting it. Make sure you run density tests on the base. Make sure everything is pretty nice and compacted. 100% modified Proctor for compaction for your base material. And to start putting the paver on, you lay it out there, put them right next to each other. Typically, if you got permeable paver, you got aggregates in between the pavers. Okay, here's the kind of another slide showing the base, and then you put the paver on top of it. Traffic loading, again, as we discussed, we use this for parking lots. These are various uses of pavers. They're beautiful. You can carry loads. You know, you got a fire truck. So road reconstruction. So one of the things we want to know, if some of these pavers, what kind of a infiltration they have, how much water can go through them and stuff. So we picked a location. We use this device in here. It's a kind of a cylindrical thing, about 12 inches in diameter, 24 inches tall. This is the ASTM standard for running the test. And you go in there and put some plumber's putty in there because we don't want it to leak. Put it in, and then you slide that on top of it. Um, yeah. Still don't see any questions, so I don't know if there is a question or not. But anyway, um, you put that cone in there, the cylinder on top of it, and make sure it's sealed. Make sure you seal inside of it. It's gonna be nice and sealed out there. You add water to it. And basically, you put a bucket there, you weigh it, and then add water to it. You add about 8 pounds of water. Just pre-wet it with 8 pounds of water, and then you pour water in there. If the water sits there and it doesn't go anywhere, you add another 8 pounds. You just kind of monitor it and see how fast the water flow through it. If it goes through within 30 seconds, then you add 40 pounds of water to it, and you kind of monitor the water flow through it. This kind of shows the test that it's run. It's the plumber's putty. You can see the cylinder. Uh, you got the water just sitting there, not going anywhere. If the water's not going anywhere, you add another 8 pounds of water to it, and try to run the test. And if it's not going anywhere, you measure the infiltration. In this case, water starts flowing. So you measure basically infiltration through the pavers as a function of time. So in this case, our infiltration test showed 4 inch per hour, 4 inches of head dropped per hour, which puts it right in here with 8 pounds of water. That means this thing was dirty, needs to be cleaned up. Essentially clean immediately. That's the red part. It says clean it. So it's kind of slow on this thing. So we picked up a case study for a project that had permeable pavers, rain creek. That's the kind of commercial name for it. And they want to know how permeable it was. It was basically a case where there was a dispute about how permeable these permeable pavements are. So we compared that to natural soils, and we compared it to concrete paving, and of course we compared it to permeable pavers. So for that, we did field work, field exploration, lab testing, engineering analysis, and results conclusion. So this is the kind of an impermeable paver, just basically a colored concrete kind of pavements. It's impermeable. That's the permeable paver. It's a nice system. It's very permeable. And of course, here's the natural soil area in the backyard of the residence, where we tested the natural soils to see how permeable this is. The infiltration test we did was in according to ASTM C178781. Here's the pavement. We did put the cone in here, the cylinder, and put the plumber's putty, weigh the water. We pre-wet it with 8 pounds of water. Within 30 seconds, all that water went away. Here's pouring the water, and you can see how permeable this paver is, and the water just runs right out of there. You can't hold any water. That's very permeable paver there. Then we pour more water in there. You get a whole bucket of water. Still wouldn't hold it. That water just flows right through it. It's a great system. This drain-crete system is a pretty good system. It's got underneath it, it's got gap graded rock there, limestone base. So it just, any water we put in there just went away. We took it off. Here's another one. We actually putting a water hose in there because it used up all the water in the bucket. So in this test, we just put a water hose in there to see how much water it can hold, and it just sucked up all the water. So it's so permeable that even if you put a water hose in it, uh, this thing basically drains right through. Here's another one. Test C1 near the driveway entrance. We ran another test out there on another part of the permeable paver. Again, put the cylinders there and put the putty on it. Put water in it, pre-wetted with 8 pounds. Within 30 seconds, all the water went away. Again, the same thing. Put a lot of water in there, a bucket of water. That's another test location. And you can see how permeable it is. In fact, you put a hose in there, it does the same thing. It uses up all the water. Basically, all the water will go through. They're just pouring water and the water goes away. Now, one of the things we did, of course, we said this is permeable, but they want to compare that to the natural ground because the attorneys will say, well, we want to show that this is more permeable than natural soils. And so we went out there and set the cylinder up on top of natural soil, drive into the soil, and then be ready with 8 pounds of water. You had, of course, the plumber's putty. Yeah, and you can see in here, you got the grass. We start pouring water in it. Starts holding water. You know, we start pouring more water in it. It was holding water. Water did dissipate within 30 seconds. So we had to add another 40 pounds of water to it. We measure the water drop as a function of time. In this case, for natural soil, we found it was 1 inch per hour. So the head dropped 1 inch per hour. And for permeable paver that were dirty, they were 4 inch per hour. So basically, the water, natural soils was pretty bad. It only 1 inch per hour. There was not that much drainage on natural soils. So the attorneys asked us to do, well, why don't we just do the infiltration test on a regular concrete? So we went out there and they had a concrete drive, solid concrete. It was patterned. And so we set it up over there and we weigh this thing and of course put the plumber's putty, sealed it, and we started to add water to it. Again, this is patterned concrete. We expected it to hold water, no water will go away. So we poured the water, it was sealed, just sat there. Didn't go anywhere. We measured permeability of 0 per hour. We monitored for 1 hour, 60 minutes. It was 0. Water just sat there. So here's another video again. We poured more water in there, 40 pounds of water to see what it does. And as you can see, water just sits there. It doesn't penetrate anywhere. That's impermeable, regular pattern concrete. So we took it off. All the water came out of the bottom. Yeah, we put more water in there again. Water came out. So pattern concrete had a permeability of 0. Again, on test C1, we put a hose in it right here on that driveway, of course. This shows no matter how much water you put in there on the permeable pavement part, water just basically goes away into the reservoir of the aggregate underneath it. So it's an awesome product. And you can see the water just going in there. That's the test number C2. This was C1, C2, and we have, of course, C3. Here where we did the impermeable tests on this natural soil. And here's the impermeable paver right here, this regular pattern concrete. This is C2. We put a hose in there and just everything goes. So what we measured based on ASTM C178, C1, C2, and C3, we had more than 1,200 inch of water per hour. I mean, that water just flew right through it. What natural soil was, the permeability 1.0, which was 1 inch per hour. For impermeable concrete right here, we had 0. The water just sat there, didn't go anywhere. So for basically comparing that, the permeable pavement to impermeable paving, okay, this is permeable paver. This is here permeable pavement. A good permeable paver drains at a rate of about 11.75 inches per hour, which is very close to what we measured here for permeable pavement. So they are equal. So a good permeable paver drains as good as the rain creek we tested, unless they're dirty. That basically they got to get cleaned up. Natural soil was 1.0, permeable concrete was 0. So we went out there and see what we got over there on that permeable pavements, what the structure of it was. We did some coring, drilling, sampling, and backfilling. So the design was 4 inches of compacted rain creek permeable pavement for a residential driveway. Below that, we had 4 inches of gap-graded limestone, and below that, we had natural soil, compacted. Key specification for raincrete, which is the material that was used for permeable pavement, natural soil without debris, wasted, basically compacted. They said that the system will have a permeability of about 288 inch per hour. Our test showed greater than 1200 inch per hour. Base material consists of ASTM C33 concrete aggregates, 100 passing number 1.5 inch, 95% to 100% passing 1 inch, 25% passing through half an inch, and 0 to 10% passing number 4. So we core this thing here. That's coring C1. And that's what the aggregate looks like here. Basically, raincrete. You can see it like that. It's got gap graded aggregates, and that's C2. That's the core that we did. That's C2. That's what it looks like when we core it. Use water to do the coring. This is C3 core number 3. Again, we core it. It looks like this. That's how the water flows right through it, because a lot of voids in it. Below that, we found this aggregate. It's a limestone aggregate, gap graded aggregate. We tried to get some sample underneath it. We found fabric and then natural soil. It was a sandy clay material, lean clay. We used a portable rig we have to get our sample. We did the same thing with the natural soil. We went in the backyard, see what kind of soil we have in the backyard, and we got samples of it. After we got the sample, we backfilled the hole with gravel. Well, actually, in the backyard, we used the topsoil to backfill the holes, and in the I think in the paver areas, we used aggregate to fill the hole. They had to come back in and repair them. Laboratory testing, we did some classification tests, strength test, and gradation tests on the aggregates. The soil, basically, we found 0 to 2 feet consisted of lean clay with PIs between 18 to 29, strengths of about 0.31 to 0.62 tons per square foot. Moderately strong, low PI, essentially. 18 to 29 is not that expensive. We talked about the specifications of the raincrete. What we need in terms of aggregate size. We ran the test on the gradation, and again, we found that basically everything went through a number 3/8 of an inch sieve, and it was classified as coarse aggregate. And you can see a straight drop in here, so this basically tells you it's gap graded. Here's another sample. This one here, that's boring B2. The first one was B1, and the first one was B1. This is B2. Again, they're both the same. The gradation in here, they all classify as coarse aggregate. So basically what we did, engineering analysis, we looked at permeable pavement structure, field infiltration tests, and comparison of infiltration rate in permeable pavements and permeable pavers, and natural soils and impermeable concrete. So for a residential street, we had 4 inches of this raincrete, and that 4 inches of surface course underlain by 4 inches of gravel or limestone. Then had a geotextile fabric. Topsoil consists of basically lean clay. And the permeabilities that we, of course, measured, which is for a clean pavers and pavement, permeable pavements, the flow is going to be more than 1,200 inch per hour. For natural soil, we measured 1.0 as 1 inch per hour. Of course, impermeable was 0. So the field infiltration test, a review of the infiltration test, the pavements indicates that infiltration tests for basically pavers, permeable pavers, and permeable pavements is more than 1,200 inch per hour. Infiltration test in natural soils was 1 inch per hour based on resultant infiltration tests. Permeable pavement permeability is much greater than natural soils for infiltration. Comparison of infiltration rate of on-site permeable pavement and permeable paving. The infiltration rate for the one we tested for permeable pavers was 4 inch per hour, which was dirty. The infiltration rate for permeable pavement we measured was 1,200 inch per hour. The infiltration rate for natural soil was 1 inch per hour. For concrete, just solid concrete, was 0. Therefore, permeable pavement had superior infiltration rate compared to permeable pavers. Although they're going to have very similar infiltration if the permeable pavers are clean. Based on the results of our analysis and field and laboratory test results, it is our permeable pavement pavements at the project site in Houston is permeable because the homeowner association was talking about these things being impermeable. We showed that these permeable pavers are permeable. One of the things we have to do with the permeable pavers is make sure it's not dirty and it's cleaned properly. So you can't just fill it up with sand. Basically, a clean one, you need to have a permeability of about 1,200 inch per hour, or it says 1175. You can blow out this stuff out of this seams in here, and you put aggregates in them. You can vacuum it, pressure wash it. You'll clean it up with pressure washer. If you're doing landscaping, if you put soils on top of it, it's going to plug up all the permeable pavers. So you don't want that. You want to put a plastic underneath it when you do landscaping, so that these permeable pavers do not get clogged up. Here's the kind of a maintenance table that I've seen in the manual. If you got clogging, schedule appropriate routine cleaning 1 to 2 times a year. You go out there and vacuum it or pressure wash it. Clogged, damaged secondary features. Clean up the repair secondary drainage features. Annually, you got to do this. If you got depressions or settlements, repair the pavements, pavers, depressions exceeding 0.5 inch. Annually, repair as needed. Rotting, again, repair all the pavers servicing rotting and exceeding 0.6 inches. You know, you may have to go out add more aggregate underneath it to make it more level if it's raw, if it's depressions. Faulting, repair the pavement surface exceeding 0.25 inches annually or semi-annually. Damage to paver units, you got to replace them. Edge restraint damage, replace the pavements and offset by 0.25 inch. This is going to be in the manual. Excessive joint width, repair pavements exhibiting joint widths exceeding 0.5 inch. Joint filler loss, replenish with aggregate. Horizontal creep, repair the areas that are experiencing creep. If it must be on a slope or something, if it's creeping. Excessive settlement, go out there, remove the pavers, and find out what the cause is. You may have to add more aggregate underneath it to just level it. So these are annually or as needed. You got to do these repairs. Questions? I don't know if you can do questions on this. Again, we're still working on the technical end of this thing here. I don't see any question. Any questions?